Hey guys, Terry Hay here again from Shock Treatment, and today we're going to be looking at the KYB SSS Fork. Now the KYB fork has been around for many years. It first came out in 2005 and we've seen a bit of a design evolution since that day occurred. And so 2005 was not a great fork, let's face it. 2006, pretty good. 2007 was better again. And largely since 2007 we've seen a few tweaks here and there, and you know, tweaking was all that fork needed. I mean, it was a pretty sound design, but generally the KYB fork is regarded as the best quality stock fork that you can buy. Never used to be that way though. Like, we had other contenders, the Shower fork, the WP bladder fork. All of these companies could give KYB a run for their money, but they've gone off chasing things like Air Forks, 4CS, Explore. And so we've seen the decision to come up with something different hasn't been a forward step. Now what we find is KYB are left out on their own, but the way you hear the industry talk now, it's like it's some form of alien technology that has been bestowed upon the riders of Earth, and it's the greatest thing since sliced bread. It's just a fork. It has its problems, and we can make it better as well. And we'll go over some of the changes that they've made and why they've arrived at their present state. Okay, let's get into it. Right, well, we've pulled our forks down. Let's have a look at them. We've had to move out of the workshop. We packed the workshop away. The guys have gone home. Too many bikes in there and no room. So we'll find ourselves in the shock treatment waiting area at this point. Nonetheless, let's do it. Okay, so we have a 48mm upside down fork. Really nice fork design, has good flex characteristics, and fairly decent seal mechanism in here as well. And so this has been a very sound design and good reliable fork with pretty good seal life. As for the cartridge, we've pulled the damping rod out of the cartridge at this point. So we have our standard damping rod, mid-valve and rebound on this piston, and nice looking cartridge. Fairly basic coatings that we've got on here, although we do have a Kashima coat on the pressure mechanism, on the pressure chamber, and that assists with reducing friction within the fork. Now, early on they had a spring backup on the mid valve. In this particular case, it doesn't run a spring. It's what they call a trampoline. It runs a secondary shim stack. And basically the secondary shim stack is applying the spring force for the mid valve. With this particular setup, of course, the mid valve is sitting solid against the piston face, and it takes a reasonable amount of pressure to move it. Personally, I prefer mid valves that have got a little bit of float. Now, we also have our compression valve and we have our pressure mechanism. In this particular case, the pressure is provided by a plastic piston and it has a backup spring. And so after you've bled the cartridge and you go to insert this in there, what you'll find is it actually requires a little bit of pressure to house that in there, and the oil volume inside that cartridge will create resistance pushing that piston back, and it's that initial preload that you put on that spring that creates the pressure within that cartridge and stabilizes the fluid volume. So all pretty standard. All in all, we've got a pretty good fork design here. The few things I don't like, as I said, I don't really like this solid set mid valve. I'd much prefer that we had a backup spring and we could actually introduce a little bit of float to here. And another thing I don't like is the size of this piston. The piston is just way too large. Now, if we look at our piston, it is a 35mm piston and the flow through that is massive. Okay, so if we look at the combined port area, it is basically 3 or just over 3 times the area of that rod. And so it's that rod that's entering the cartridge that pushes fluid through that valve. Now, damping is velocity sensitive. And so what we'll find is if we didn't have any shims on there whatsoever, I mean, this is attached to the axle and it's basically moving at wheel speed. And what we'll find is that the fluid passing through here now, because the area is over 3 times what the area of this rod is, we'll find that the fluid movement basically is slowed down through that valve to 1/3 of the wheel speed. Damping's velocity sensitive. we could really use some speed here. Now, one thing that suspension theory has long done is it's flown in the face of hydraulic theory and fluid dynamics. If you come down to basic hydraulic theory, it's pressure over an area that actually creates your force. And so we've got the damper rod supplying pressure and it's working over the area of that valve. And so if we look at it and we think of it like a jack, this is basically like the little plunger on the jack, and this is like the ram. And so we'll get a multiplication of force as the fluid is applied over that valve area. And so what we need, we're generating with those large pistons, we're generating an enormous amount of force at the shim stack. And I'll just show you here, the shim stack on that valve, it's massive. Okay, that is a very, very burly shim stack. And so it's required to be that way because there is so much force because of the area. Okay, simple hydraulic law. And so we need to have that valve, that shim stack so stiff in order to resist the force. But anytime you make a valve heavier and heavier and heavier, we have what we call valve lag, or in technical terms, a moment of inertia. And it can become very difficult. Well, not so much difficult, but it has a higher level of difficulty in opening that valve than what you would have on a smaller unit. And so what that will mean to the rider is the smaller bumps generally feel a bit harder than they need to be, but because that area is so large now, when that valve does open, it opens up over such a large area, and we're dealing with such a small fluid volume that volume can piss through. Okay, so stroke control becomes very, very hard to manage, bottoming resistance, etc. And so what they've done, they've created a whole lot of compensations within this fork. And those compensations start with, if we have a look at this area here on the valve, okay, there's a secondary shim stack. And what that shim stack is working on is the actual fluid volume that's passing through the adjusting circuit. So they've put that secondary shim stack on there to create a little bit of extra stroke control. And because they don't have any float at the mid valve anymore, basically we need to create extra force in front of the piston to now drive that fluid to the back of the mid valve piston, ready for the rebound stroke. So that's some of the issues. Let's look at some of the cures. So, how do we make this fork better? Okay, like I said, there have been a number of compensations in this design, and we find people, quite often trying to make a few wrongs make a right. And where they're at the moment with this design is it feels quite nice, it works better than a lot of the other products that are out there at this point in time in terms of rider feel. In terms of the mechanical application, probably not working as good as it could. So if we're going to tune this and we want this thing to work better, personally for me, I much prefer to put a spring arrangement on the mid valve and refocus our attention on the rebound here as well. The latest rebound settings from these are a little questionable, and so if you were to bring your fork into us, we would change this to a spring style setup on the mid valve, and we would reconfigure the rebound damping also. If you wanted to keep costs down, we could certainly take this valve off and we could reconfigure that shim stack. By simply changing the quantity, the diameter or the thickness of these shims, we can tune for an effect, and we can create more bottoming resistance, better initial feel. There's a scope of tune that's almost limitless. If we wanted to go beyond that and to get into something a little bit more elaborate, and personally with this fork, I really don't like that valve. Okay, it is way, way too large for mine. Okay, so now what we can do is a US company called Racetech who make the smartest valve I think I've ever seen. And so this is what we call a G2R valve. And not only does it allow you the normal scope of tune, you can change all the valve settings to suit whatever weight, whatever skill level you have from your rider. But on this valve, it has a unique design Has little side ports there, and you see the port area is already smaller than what you get from the normal 35mm piston, but it has this recess. Now that recess is 1mm deep, and what allows us to do is actually build a restrictor into that valve face. And so by building the restrictor, we can use different size shims, and we could run a 20mm shim, a 22, 26mm shims, and we could shut that port area down, which dramatically alters the velocity of discharge through that valve. And so for mine, whenever we set up these, we use a 26mm restrictor. And as you can see there, it has dramatically shut that port area down. And by doing that, it's basically like putting your thumb over a garden hose. You'll find that you've got the same amount of fluid coming through, but you've changed the discharge velocity. Now, damping is velocity sensitive, right? So anything allows us to tune the velocity gives us a much, much more enhanced scope of tune. And by running a restrictor in there, what we'll find is we actually dramatically back off the number of shims that we're using. And so we'll possibly use, say, a third of the amount of shims as they've got in the standard valve. Now, by doing that, basically we reduce the weight and the force of that shim stack, and so the opening pressure becomes a little easier. And making that valve easier to open actually means that our small choppy bumps are enhanced, and we'll get a plusher, more capable ride, if you like. But by increasing the velocity, as I said, damping is velocity sensitive. By ramping up that velocity, we'll find that on the larger hits, we get a lot more bottoming resistance with a more restricted valve setup. And so there are people out there who would probably say, well, hang on, the whole gold valve theory was large port. And it was. The gold valve was invented back in 1991. And back in those days, we had our forks pushing oil through a 20mm piston. So a 20mm piston, it's tiny, and they only had 3 tiny little ports. And so we still had the same size damper rods. We still had a 12.5mm damper rod pushing oil through these 20mm pistons. And so we would see a dramatic restriction in the oil flow to the point that it was too restrictive. Because oil won't compress, basically on the bigger hits we'd end up with what was essentially like a partial hydraulic lock, and that created a lot of harshness for the rider. So for Paul, Paul Thie, the inventor of Race Tech, he took this concept and he engineered new valves which had larger ports, and straight away the plushness improved, and he'd find that rider fatigue was dramatically improved, and also just general stroke control. So the fork was a lot more compliant, worked a lot nicer, and the gold valve was born. And so a lot of the industry now have moved towards the gold valve theory, and they're making their pistons larger and larger and larger. But we've got to the point where they're just too large. And so we need to shut this down, and we need to restrict it to create the control that we want. So if you've got a set of these forks, seriously, like, you can revalve it if you like, and you can get a good result. But if you want to get the best result, this thing is awesome. And so not a lot of money in terms of what you'd spend upgrading your motorcycle, and the result that you get is basically, if you were to put a value on that result, it'd pay for that valve 5 times over. Right, so we've looked at our valving. We've discussed revalving the standard gear. We can put the gold valve or any aftermarket piston in there. If we want to take things a little better, we can reduce the friction. And as I said, the coating on that standard cartridge, it's okay. It's nothing special. These are my own KYB cartridges, and we've sent these out. We've had them nickel Teflon plated. You can see the finish is a little bit different to the stock unit. And these things are just buttery smooth. It's a really, really lovely finish. Not only did we do the cartridge, but we did the damping rod as well. And everybody that rode on these forks was really, really impressed with them. Their freedom of movement, their stroke control was magnificent. As I said before, you've got a Kashima coat upper cartridge, so we didn't actually change that. And Naturally, we ran the gold valve in there as well. But if you want to go beyond that, you can put cartridges in there. And as I said, we created a really nice factory fork, if you wish. And really impressive. But one of the guys said, why don't we try a different cartridge in there? And we put a set of Soggio spheres. And it was a bittersweet moment. I mean, I really love the Soggio spheres, but this was my baby. And we did everything we could to these KYBs, and still the Soggio spheres outperformed them. So yeah, lovely fork. Can they be beaten? Yeah, they can. Okay, so we've looked at the design of this fork, we've looked at how to tune the standard gear, possible replacement valves, replacement cartridges, low friction coatings, etc. Now, let's look at some durability issues, and they've had some big ones over the years. 2005 was a challenging time for anybody that had a set of these forks, and the reason was that this plastic piston here was positioned way too high in the cartridge, and so the piston's job was to basically provide pressure and obviously regulate the fluid volume within that cartridge. And as the forks compress, this piston would move up and down, and on the larger hits it would actually, the O-ring would come up and it would move beyond that tapered section, and because it got into the taper, oil could exhaust itself in the cartridge and it would move around that O-ring and it would be vented out of that hole. Now, this was necessary if you didn't regulate the volume on every bottom out situation, because it uses the bottom of the cartridge as its bottom out mechanism. There's a cup, and that cartridge will come down into that cup. Oil pressure builds dramatically, and some of the oil will actually get forced past that seal and increase the volume inside that cartridge. If we didn't regulate the volume, what we'd find is that cartridge would explode. Okay, but so in 2005, the piston would actually vent early and would see a discharge of excessive fluid from that cartridge, and it meant we had a low fluid volume in there, and that fluid would create then a negative pressure. Okay, we're trying to elevate performance with a positive pressure mechanism, but we ended up with negative pressure. So very simple solution. It was just a case of calculating what volume we required inside that cartridge and repositioning that piston further down so that it would regulate the volume at the correct rate. And so it was necessary to put an 8mm spacer in there. That spacer just went between the plastic cup and the spring itself, and that would then exhaust at the correct position, and we had a positive pressure cartridge again. Now, with this particular unit, you can see it's vented. Okay, and so the reason that it's vented is because oil pressure traditionally used to build behind that piston. Oil would get forced past that seal on bigger hits, and the oil volume would build until it got to a point where it was way too much, couldn't handle it anymore, and on the bigger hits, basically because oil won't compress to any large degree, it would then shatter these pistons. And so here's a couple here that have had the tops just blown straight off them. And so we end up with a catastrophic failure in this particular case, and that was very common. And so the aftermarket made a killing in creating these aluminium replacement pistons for these forks. Now, there really wasn't a need for them to be made out of aluminium, but we certainly needed to manage the oil buildup. And so in 2005, we started venting these particular pistons. And when you put that vent in there, it relieves all that pressure, and it also negates the SSS system. And so the thing about the SSS system is when you negated it, the fork works so much nicer. So everyone raving about the SSS, I don't get it. You know, they're just quoting the brochure as opposed to actually testing and finding out what worked best. And so because we created that vent, it then broke the seal, and it then allowed us to actually remove that secondary O-ring, and by removing that lower O-ring, it actually reduced our friction again. So we got better wheel response, better grip levels, and that was a lovely improvement. And after making Yamaha aware of this problem in 2005, you can see that they've responded 13 years later. Fast, eh? Anyway, that's our KYB fork. Hope you've enjoyed it. Stay tuned for the next video.